In this lecture, we'll be looking at 8.2, trigonometric polar form of complex numbers. So trigonometric form and polar form are the same thing. First, we want to know, how do we graph complex numbers? A complex number has a real component and an imaginary component. The real component is like the x component of a vector, and the imaginary component is like the y component of a vector. So for instance, if you were to think about the vector 2, 3, how would you graph this vector? You would graph it like this, right? That's the vector 2, 3. So that's also the way that you graph the complex number 2 plus 3i in the exact same way. So now let us look then at my Open Math Homework 23, number 7. We need to plot -2 plus -1i. Now this is the same thing as if they were to write -2 minus I. Same thing. And so what we want to do is look at the real number for the x direction. So we want to go back 2. And then we want to go down 1 because the imaginary component is going down 1. So we would end up with what looks like a vector down here at -2, -1. And you can see that is drawn in the same way. Now, sometimes in some places you see it represented as a dot. And in other places you represent it as vectors. So for instance, when we were back over here, we saw that these complex numbers were drawn as vectors. And then we see over here on My Open Math that it's drawn as a dot. So when you're on My Open Math, go ahead and use the dot method. But you'll see that in your book it's drawn in this way. Okay, let's look at how to convert from trigonometric form to rectangular form. First of all, what is trigonometric form? Trigonometric form is the form r times cosine theta plus I sine theta. Sometimes it's also written as r c I s theta. And the CIS represents cosine, I, and sine, and theta. But we're going to go ahead and just look at this first version right here for starters. So let us go back to the example. And you see r cosine theta plus I sine theta. So all we have to do is replace cosine of 135 degrees with -√2/2 and sine of 135 degrees with √2/2. And so then this expression becomes 10 times -√2/2 plus I times √2/2, and then you simplify it. So it's really that straightforward. So let's look at questions 8 and 9 now on My Open Math. So here we have this complex number is written in polar form or trigonometric form. Remember that polar form and trigonometric form are the same thing. In this case, they're using radians, but whether you use radians or degrees, it doesn't matter. We just need to change this to the a plus bi form. So the first thing we want to do is rewrite this, replacing cosine of pi over 6 and sine of pi over 6 with the values from the unit circle. Then next we distribute the 6, and we end up with 3√3 plus I times 3. But if we're going to rewrite this in the standard form, then we need to rewrite it with the I on the right-hand side. So this would be 3 times the square root of 3 plus 3i. Now here, they did not write it as 3√3. They wrote it as a decimal approximation, but you still need to write it as 3√3. Sometimes My Open Math shows decimal approximations that they use to check your answer, but they don't necessarily want your answer in that format. So I'm telling you just to write 3 root 3 plus 3i. Now let's come down here to this version of it. Remember that the CIS form means the same thing as the expanded form I showed you. So if you want to expand it, you can, and this is what it would look like. So the CIS form unpacks to cosine I sine. So we have 5 times the cosine of 120 degrees plus I times the sine of 120 degrees, and now we're going to replace cosine 120 and sine 120 using unit circle values. And then next we use the distributive property, and then we want to rewrite this also in the a plus bi format. So we have negative 5 halves plus 5 root 3 over 2 times I. So again, they have chosen to use decimal approximations for their grading, but these answers right here are the answers that My Open Math is going to be using to check your work. I would still advocate that you use exact answers wherever possible. That's the safest way to go. Okay, so next we get to look at converting from rectangular form back to trigonometric form. So this way is a little harder. What you have to do is you have to draw your value as a vector. And then once you draw it as a vector, you need to figure out what the r value is, and that would be the length of the hypotenuse of this right triangle. And then you need to figure out what the theta value is, and the theta value here is 315 degrees. So once you're familiar with the basics of trigonometry, this is really not that hard of a conversion. So let us look then at questions 10 and 11 from My Open Math. So we are converting into polar form or trig form, starting with the number negative 9. So what you want to do is you want to start out with graphing the values. So if I were to just make my xy plane right here, then the number negative 9, that is a real number, and the real number negative 9 is going to be in the negative direction on the x-axis. So I'm just going to say that this is where negative 9 exists here. I'm drawing a notch, and I'm saying this is the negative 9 notch right here. Okay, so given that this is where it's located, the length of this vector is already just going to be a positive 9. You don't have to use Pythagorean theorem to figure that out. And then for the angle, well, the angle is really easy to figure out too, because you just start at the positive x-axis and go to the negative x-axis, and of course that's 180 degrees. But pay attention to the fact that the directions do require radians. So that means that r is a positive 9, and your theta value is actually pi. And then when we look at this other value, negative 10i, the y-axis is your imaginary axis. So the x-axis is the real number line that you learn about in elementary school. The y-axis is your imaginary number line, and together they make the complex plane. So down here we have negative 10i, so this notch right here is my negative 10i notch. And then of course the radius length would be a positive 10. Starting from the positive x-axis and coming around here, this is 3 pi over 2. So these are the simplest ones to do because these lie actually on an axis. You can see here that the values then are 9 and 10 with pi and 3 pi halves, just like I said. Okay, let's look at question number 11. Here we have again radians, and we are rounding to 3 decimal places. It's always very nice when they include that. and our point is 3, -15i. So let's start with our graph. Okay, so here is my xy plane. This is the complex plane, so the real numbers are on the x-axis and the imaginary numbers run down the y-axis. So what I need to do is go to the point 3, -15, which is this point right here, and I have to manage to draw now a straight line. This will be my really difficult thing to do for my whole day. And no, I did not succeed. Okay, well, assuming this had been a straight line, this is not my skill set, drawing straight lines with a mouse. That is your 3 minus 15i right there. So what is the r value? Pythagorean theorem. So r is equal to the square root of the real component squared plus the imaginary component squared, the imaginary coefficient, not the entire component, just the y part. So this form right here that you're looking at is x plus y I. Okay, and so the formula that I'm using right here is that r is equal to the square root of x squared plus y squared. Now notice you don't square the I, you only square the y in front of the I. So when you simplify this, you end up with 3 root 26. But the Myopen Math wants to have a decimal approximation of that. So 3 times the square root of 26 approximates to 3 decimal places as 15.297. Now your theta value runs from the positive x-axis all the way around, and we need this to be in radians, and we need it to be between 0 and 2 pi. So we can look here at the fact that the tangent of theta is equal to y over x. And so we can rewrite this now as -15/3. And then we can type that into the calculator. Make sure you are in radian modes in the calculator. So I'm going to switch to radian mode, and then I'm going to do the tan inverse of, well, that's -5. And you will get a negative number. So what you'll get is your theta value is, according to the calculator, -1.373. But don't keep this value, because this value is not between 0 and 2 pi. So what we want to do is we want to add 2 pi onto that value to find something coterminal that is in the 0 to 2 pi window. And then we end up with 4.9097, which that rounds up to 910. So we have 15.297 and 4.910. They only wrote 4.91. It is 4.910. We are rounding to 3 decimal places. Okay, so that's it for 8.2. The next lecture will cover 8.3.